we've kind of implicitly used all along. Okay, we've kind of used it all the time. But today we kind of do a formal definition of that theorem. And it's called the linear factorization theorem. Okay, it's called the linear factorization theorem. And it's like I'm saying that we've kind of used this before. Okay. So today is just a formal introduction and the actual words in the theorem and so on. So what the linear factorization theorem tells you is that if you've got a polynomial like this guy here, okay, it'll have, actually, there's another theorem before this called the fundamental theorem of algebra, FTA, okay, called the fundamental theorem of algebra, which says that if you've got a polynomial with degree 2, then it'll have exactly 2 zeros, okay? And we're not saying anything about whether the zeros are real or complex or rational or whatever. There'll be 2 zeros, okay? They may be complex. They may be complex. The linear factorization theorem tells you that such a polynomial can be factored into these linear factors. So, for instance, this is a linear factor. Does anybody know why this is a linear factor? X minus 2. Why is that called a linear factor? You guys know what a factor is, right? What's a factor? A number, or in this case, something that goes into, okay, without a remainder. Why is it linear? Sorry? Oh, wow. Exactly, Ray, exactly. Because it's x to the power of 1, okay? X to the power of 1. That's why it's called linear. Okay? So that's essentially what the theorem is telling you. And again, like I'm saying, that this is common knowledge. We've been using it all along. Today we're just going to kind of formally introduce it and make statements about it. Then my claim is, yeah, if you have not gotten this, don't feel sorry for you, because you come in BS in my class, you get left behind. Now my claim to you is that this guy can also be written as a product of 3 linear factors. So in order to write things down as 3 linear factors, you go to first find out its zeros. And I shall pause here because this you should know how to do. Okay, you guys got this? Yeah. Because remember what Descartes says. Descartes says it's either this number. Shh. Okay, Mariam, you're out of it. Come and sit here in the front. Forever and ever and ever. Out here. Out here. Mariam, out here. Out here. Out here. Okay, thanks. Descartes says it's either this number or an even number less than that. So 3 minus 2. 1. So the other one's got to be complex. There are no negative roots here because you can see there are no sign changes there. Total is always whatever this highest degree is. Always. That's the fundamental theorem of algebra. Yes. So 5 will go to 3. 5 minus 2.
5 minus. So you always minus 2.
Always minus 2. An even number. Okay, so 5 minus 3 minus 2, 3, 3 minus 2, 1. I think this looks good. Perfect, perfect. Okay, so here's the real stuff, okay? So this is the linear factorization theorem. Okay? So again, notice that we are not talking about the zeros or the roots being real, okay? They could be complex, as it's implied in here, because they're using the letter C, okay? Now notice that complex also means real. Okay, so in other words, complex is a superset, okay? Because you got complex numbers. Inside them you have real numbers. Okay? Inside the reals you have rationals. and then you have the irrationals. Okay, so when I use the letter C, it means that it could be any one of these kind of numbers. It could be complex, it could be just real, could be rational, could be irrational. Okay, so that's what the linear factorization theorem says, that any polynomial, so this has got to be a polynomial, okay? It's got to be, everybody knows what a polynomial is, right? Yeah? No? Yes? No? Yes? Okay. Okay, so I'm going to do an example like problem number 52 on page 145. Sorry? Go up to the previous one? So they give you a polynomial and they give you a factor and they're asking you to find all the remaining factors. Find all the remaining factors. So the fact that they give you 3i's a factor, it means that you've got to have this guy. Okay? And we guys have done complex numbers before, we've done complex roots. What did we learn about them? They always happen in, sorry? They always happen in twos or in pairs. That's why in Descartes you decrease by 2 every time. Okay? So if 3i is a root, then what is the other one going to be? For sure. It's conjugate. Okay, so you know that x equals minus 3i is also a root because complex roots always happen in pairs, in conjugate pairs. So then this other guy is going to be x plus 3i. Okay, and then we need to find one more. We need to find one more. Okay, we need to find one more. Now a problem like this, it's probably best to just fold this out. Fold these guys out. And I'll write it down as x squared plus 9. Everybody catch up with me on that, please. I'll give you a minute to catch up on that. Yes? Always. Yeah. Always. Yes, good. Okay. Is everybody okay with me foiling x minus 3i and x plus 3i? Did everybody get x squared plus 3 plus 9? Hello? Okay. Yeah, that's it. So yeah. You might want to help. Elizabeth, can you help him? Okay. Everybody caught up with me on x squared plus 9? Do I need to go over that foiling? Is everybody okay on that? Yes? What do you think C is going to be then? What do you think C is going to be? Sorry? Well, take a look, okay? You know that when you foil the thing, this number times whatever this number here is got to give you, that's the only way you're going to get a whole number out of there. Only way. So it's going to be 1. Okay? Is everybody with me on this? Okay. Zal, look up, okay? When you have, you know that there's going to be a number in here, right? Let me just kind of erase this thing out and put a different color in there. Okay? You know there's going to be some number in here, right? Yes? If you take this number and this blue dot, that's the only way you're going to get a whole number without an x in it. If you look at your question, which is the whole number without an x? 9. So the only thing that this blue dot could be is 1. So everybody with me on this? Okay. Okay, you guys work on this one here. Given zeros is 2i minus I. Write the polynomial with integer coefficients. So all they're asking you to do is foil the stuff out and you get a polynomial. Everybody see where you get x minus 2 from? Right? Because 2 is a root. X minus I because I is a root. And x plus I because minus I is a root. And the way you want to FOIL, let me just suggest to you, the way you want to FOIL is you want to multiply the last two factors first. Okay? Multiply the complex ones first. Because that way guaranteed there will be no complex numbers. Okay? It will be a real factor. So I'll pause here and have you finish this off. I believe this is the last thing I'm doing. Yes.